Let's work on solving this equation involving several natural logs. As you'll notice, we have natural logs involved. On the left-hand side, though, we have two separate natural logs. I think the easiest way to get going on this is to begin by combining these natural logs into a single natural log on the left-hand side. So I'm going to go with the natural log over there, and I'll just bring along the right-hand side. On the left-hand side, though, because the first one's positive, that x from the inside is going to end up in our numerator in our single natural log, whereas the second one is negative out in front. What that tells us is that subtraction is going to turn into a fraction on the inside. So the x plus 3 goes down to the denominator. Now at this point, we have a single natural log on each side of our equation. What we can do is we can just drop our natural logs and set what's on the inside equal to each other. Why we're allowed to do that is because we can take each side and move it up to the exponent using e as the base. Because e and natural log have the same base, natural log means log base e. When we compose them together like this, we get this very nice canceling out. So on the left-hand side, we will be left with x over x plus 3. And on the right-hand side, we'll simply be left with 6. All right, what was on the inside of that natural log? From here, the solving down shouldn't be too bad. We want to solve for x. Well, we can't do so while it's still in the denominator. So on the left-hand side, let's go ahead and multiply both sides by x plus 3. The idea of this is multiplying by x plus 3 and dividing by x plus 3 are inverse operations, and they'll cancel each other out. However, we will be left with the x from the numerator. On the right-hand side, I'll go ahead and distribute that 6, so we'll get 6x plus 18. From here, we've got a linear equation. We want to get all the x's on one side. So let's go ahead and subtract 6x to move all the x's to the left-hand side. 6x minus 6x will cancel each other out. On the left-hand side, we'll have x minus 6x's, leaves us with negative 5x's. 18 comes down from the right-hand side. And to finish this up, we simply need to get rid of that negative 5. Well, it's connected with multiplication. So we'll use division by negative 5 on both sides, thus getting us x on one side all by itself. So x is going to equal negative 18 over 5. Or is it? Taking a look at our solution, or what looks to be our solution in this case, we have 18 over negative 5, so that's going to be an overall negative result. In fact, this one's going to be what, negative 3.6? Let's take a look at that value and check that solution. So if we go back to our original, negative 3.6, does that work as being a solution for x? So if we plug it in here, where our x is in the original, we'd get natural log of negative 3.6. So we have a negative value overall being plugged into that natural log. That's going to be a problem. It's a problem in this one as well. Negative 3.6 plus 3 is still a negative result, negative 0.6. So we have to be a little bit careful with the domain of our original equation. We have natural logs. And remember, for natural logs, overall, whatever's on the inside has to be a positive value. All right, no matter what we think looks like our solution when we get done, we have to go back and double check that back into the original to make sure it makes sense with the domain of the natural log. So in this case, because our natural log has a negative overall value being plugged in, we have to say no solution. But that's all right. We did all the work correctly. We just ended up with no solution overall. So I hope this helps out as you're working on solving some logarithmic equations and working through these. Good luck.